6.3 Graphing Radical Functions. Alright, in 6.3 we have the parent functions for our square root and our cube root function. So let's take a look at those real quick. On our square root function, it starts right here at the origin and goes up and to the right. So we have a domain of x is greater than or equal to 0 and a range of y is greater than or equal to 0. So it starts at the origin, 0, 0, goes to the point 1, 1. That is the square root function. The parent function for the cube root function looks like this right here. And it goes through 0, 0, negative 1, negative 1, 1, 1. Our domain and range are both all real numbers. Now, you don't have to remember exactly what those functions look like because you do have your calculator. You don't have to remember all of the points and everything. It would probably be helpful to know that the square root function is just a piece and the cube root function goes totally left to right. You do, however, need to remember the domain and range. So, again, just to go back over, the domain for the square root function is x is greater than or equal to 0, and the range is y is greater than or equal to 0. Domain and range both are all real numbers for the cube root function. So, let's look at example 1. It says graph each function, identify the domain and range of each function. So, first, if we graph f of x equals the square root of 1/4 x, all you're going to do is put that in your calculator and plot points. So if we put that in our calculator and plot some points, we are going to get a graph that looks like this right here. In this graph, we make a table for these points. We have points at 0, 0. We have a point at 4, 1, 8, 1.5, 12, looks like it's possibly 1.75. I'm not going to write it because I don't know exactly, and 16.2. Okay, the 1.5 may be just a little bit off as well. But for sure, 0, 0, 4, 1, 16, 2, you can see exactly whenever you put it in your calculator. So looking at, now it says identify the domain and range of each function. Well, this is a square root function. So our domain is going to be x is greater than or equal to 0. And our range is y is greater than or equal to 0. Okay. Looking at another one, if I have g of x equals negative 3 times the cube root of x, negative 3 times the cube root of x, put that in your calculator, draw your graph, and now that negative on the inside, negative on the front, shows us what's going to happen there. It's going to have a reflection, and that's why the graph looks different than the parent function did. So, using your calculator, draw a table that goes along with that, and that's going to include points. Negative 2 goes almost to 4, not exactly. Negative 1 goes to 3. We're going through 0, 0. Positive 1 goes to negative 3. So those are some exact points there. Our domain, remember, domain are your x's. It goes forever left and forever right. So that's going to be all real numbers. My range, it goes forever down and forever up. So that is also all real numbers. Okay. Make sure and highlight your answers. We didn't highlight our answers here. And then highlight your graph. If you just want to draw a highlighted box around your graph, that's perfectly fine. You don't have to highlight the whole entire graph. All right, now, you have written this table right here 2 to 3 times, maybe 4 times already this year, but I want you to write it again. The more you write it, the more you're going to learn it, the better you're going to get with it. So we have a horizontal translation. The graph shifts to the right or the left. It's f of x minus h. If I have, for example, inside x minus 2, it's 2 to the right. If I have x plus 3, it would be 3 to the left. A vertical translation makes the graph go up or down. The plus k is on the end. We have plus 7 on the outside, 7 units up. Minus 1 on the outside would be 1 unit down. If I have a reflection, it flips over the x or the y. The negative on the inside reflects over the x. So there are 2 examples there. Negative on the inside, and I think I just said that wrong. Sorry. Negative on the inside reflects over the y. F of negative x reflects over the y. The negative on the outside in front, negative f of x, examples here and here, it's going to reflect over the x-axis. Look at your horizontal shrink or horizontal stretch. It has f of a times x. Examples here and here. If I have a number greater than 1, it is a horizontal shrink for, in this example, by a factor of 1/3. You have to flip. If I have 1/2, which is between 0 and 1, like here and here, then it is a vertical or horizontal, stretch of a factor of 2. So remember, your horizontals are backwards than what you would originally think. Your vertical stretch or shrink is on the outside. The 4 on the outside tells me a vertical stretch by a factor of 4. The 1/3 on the outside here and here tells me a vertical shrink by a factor of 1/3. All the same stuff that we've done 3 or 4 times this year already. Just make sure you write down this entire table again. Okay. So now let's look at example 2. Describe the transformation represented by g, then graph each function. Okay, so if we're starting with f of x equals the square root of x, and we're going to g of x equals the square root of x minus 3 plus 4. Well, that minus 3 right there is on the inside, and it's a minus 3. So we are going to be having a translation to the right 3 units, and then the plus 4 on the end tells me it's going to go up. So I'm just going to put and up 4 units. And then you're going to put both of those in your calculator and graph them. Your graph is going to look like this. So just be sure to graph both of those. All right. And again, on your graph, just highlight a box around it. All right, let's look at another one of those. We have the cube root of x, and then we have the cube root of negative 8x. So the negative 8 is on the inside, and if you have a negative on the inside, it is a reflection across the y-axis. And then the 8 on the inside is a horizontal And since it's 8, it's bigger than 1. It's going to be a shrink of 1 over 8. Always be sure and put that factor in there. And then if we're going to graph these, the f of x is in black. The g of x is there in blue. So there's your graph. And here are your transformations. Okay, example 3. Let the graph of g be a horizontal shrink by a factor of 1/6 followed by a translation 3 units to the left. So let's do that real quick. If we're starting with f of x equals the cube root of x, and we have to write a rule for g. Remember, we have two things because there's a followed by. So I start with h of x equals horizontal shrink by a factor of 1/6. So that means I have f of 6x because it's horizontal, it's flipped. Now then, that right there just says I'm going to change every x to 6x. So now instead of the cube root of x, I have the cube root of 6x. And that is h of x. Now I can do my followed by a translation 3 units to the left. So there's my g of x equals h of x, and to the left is going to be plus 3. So now, instead in the place of every x, I'm going to put x plus 3. So g of x is equal to the cube root of 6 times x plus 3. Now, I would like for you to do one more thing here. There's a 6 on the outside of the parentheses, so I want you to distribute that. So we get g of x equals the cube root of 6x plus 18. And that's all we have to do on that one is just write that rule. Okay, so moving on. X to the 4th, example 4. Use a graphing calculator to graph 1/2 y squared equals x and identify the vertex and the direction that the parabola opens. So we're graphing that in the calculator. To graph this in the calculator, erase that so you can see, but if I'm graphing that right there in the calculator, then I have to, you notice here I've got a y1 and a y2. I can't put them both in the calculator together. So if I have 1/2 y squared equals x, I'm going to have to solve for y. So I'm going to divide by 1/2 on both sides. So then y squared equals, when I divide by a fraction, I flip and multiply, I get 2x. Now I need to take the square root of both sides. So I get y equals plus or minus the square root of 2x. So this is the plus half, the bottom is the minus half, because you have to put them in separately since it's not a function by itself. Now then, identify the vertex. So my vertex here is at, it is at 0, 0. And the direction that the parabola opens, well, you can tell visually right there, it opens to the right. So there's my vertex, it opens to the right, and just sketch what you get from the calculator. On those where it says use a graphing calculator, I do want to see what you saw, but you don't have to make it an exact graph. Just sketch it, and that way we can definitely see the vertex and the direction of the opening from the graph. One more, use a graphing calculator to graph x squared plus y squared equals 16. So if I start here with x squared plus y squared equals 16, you're still going to have to solve for y squared or for y, so subtract x squared from both sides. y squared equals 16 minus x squared. I just put that in that order because of the negative. Take the square root of both sides and you will get y equals plus or minus the square root of 16 minus x squared. This one says to identify the radius and the intercepts. So I've got the intercepts labeled here. If I'm starting from the origin, then it goes out to 4, 4, negative 4, and negative 4. So my x-intercepts, and I would like for you to specify, my x-intercepts are 4, 0, and negative 4, 0. My y-intercepts are 0, negative 4, and 0, positive 4. Okay, and then the radius just goes from the center out to the edge. And if you go from the center to 4, then the radius is going to be 4. Another way you can look at that is this number right here on the end. If I take the square root of 16, square root of 16, that's going to give me 4. That is my radius. So there's a couple of different ways to find that. There we go. Again, I would like for you to sketch that graph and label your intercepts so I know where they came from, and then write them down as well. X-intercepts, Y-intercepts, and your radius. All right.